Hello everyone, this is Neelam Sondhya. I am a software engineering student in International Institute of Professional Studies DAVV Indore. This is my third video on the topic of exploratory analysis. We will go to the PPT. So basically, what is exploratory data analysis? EDA is a process of exploring and understanding your data before you build any model, helping you identify patterns, anomalies, and relationships that might be useful for your analysis. We will cover four essential techniques to help you to unlock the insight hidden within your datasets. We start from bar graphs with overlay, visualizing comparison, understanding overlays. So basically, what are overlays? Overlay bar graphs are powerful tools for comparing and contrasting data. By striking bars representing different categories or groups, you can visualize, highlight the proportion of a whole. This technique is particularly useful for exploring relationship between multiple variables within a dataset. Implementation of bar graphs with overlay in Python. The module import matpilot library SPLT and import pandas SPD. We can see we store data in dictionary, like we make category ABC and values of it differently. So the basic concept is we make the relationship between multiple variables and datasets. So you can see in this whole program there is a relationship between data, which is in dictionary, and the values value 1 and value 2. These are the representation in the relationship between datas and datasets. Going to the next topic, contingency tables, exploring relationships, understanding contingency tables. Contingency tables, also known as cross tabulation, provide a structured way to display the relationship between two or more categorical variables. They help you determine if there is a connection between different categories and identify potential association. Okay, the basic concept in the contingency tables are this helps in two ways. The first is different this identifies different categories and identify the potential association. You can see in implementation of Python, we use packages or modules as import pandas as PD. We are use similar dictionary ABCD, the values and key values of it, and the category second XYZ. The contingency table we store in a 1 and the data of 1 we related to 2. Second table means 2 means second table. Okay, so you clearly distinguish between the categories and the potential association. This is the whole concept of contingency tables. The third one is histogram with overlay, visualization distribution, understanding overlay of histogram. Overlay histograms allow you to compare the distribution of two or more variables. This is allow us to distribute two or more variables. This visualization help you understand how data is spread across different values and identify potential overlaps of different uh, and identify potential overlaps or differences in the distribution. This is the implementation in Python of histograms is import met.pv and import nabi as a nabi. We store data 1 and data 2. We make plt.hist, plt.hist2 and we show it. So this is the whole representation of it. We going to the next topic, binding of predictive power, categorizing continuous variables. There are three methods. First one is binding involve grouping continuous data into discrete intervals. This grouping the data into discrete intervals. This process help you summarize and analyze large data set by transforming continuous data into categorical data, making it easier to understand trends and patterns. This makes us understand to trends and patterns. The second one is binding can based on equal weight intervals which end bin has to same range. Alternatively, Equal frequency binding ensure each bin contain roughly the same number of data points. The choice of method depend on the specific data and data analysis goals. The third process, binding, can be particularly useful for predictive models by creating bins based on predictive values. You can identify groups of data points that have similar outcomes. This can lead to more accurate and interpretable models, enhancing your understanding of the underlying relationship. So these are the basic three methods of binding for predictive power. First one is binding involves grouping continuous data points. Second one is can be based on equal bit intervals, and third one is particularly used for predictive models. Going to the next slide or next topic, binding with predictive values, enhancing model accuracy. This enhance the model accuracy with the three step: predictive value, decision tree, or model interpretability. So predictive value, first one is predictive value. When binding for predictive value is the goal to create when the maximize the differences in outcome between groups. The mean grouping data points together data likely to exhibit similar behavior or result in future. Decision tree are a common machine learning algorithm often benefit from binding by creating bins that optimize the separation of outcomes. Decision tree can make more accurate prediction based on the categorical value. Third one is model interpretability. Binding can also improve model interpretability by assigning categorical labels to continuous value. You can explain the model prediction more easily, make it easier to understand the logic behind the results. The next slide, beyond the basic, exploring advanced techniques. This is exploring advanced techniques, three steps followed by this: feature engineering, dimensionality reduction, or anomaly detection. First one is feature engineering. EDA can be used to create new feature from existing data. This process called feature engineering and significantly enhance the performance of machine learning model by generating features that are more informative and predictive. Dimensionality reduction. For dataset with a large number of variables, dimensionality reduction techniques can be employed. The techniques such as principal component analysis (PCM) can reduce the number of variables with preserving the essential information in the data. Anomaly detection. EDA can be used to identify outliers of unusual pattern in data. These anomalies could indicate error in data collection, an unusual event, or hidden insights. Understanding these anomalies can improve the model accuracy. The last slide, powering your data journey with Python. There are also three steps: data exploring, data building, and continuous learning. First one is data exploring. Data exploring is utilize Python to perform EDA, gaining a deeper understanding of your data's characteristic, pattern, and relationship before embarking on modeling or analysis. Second one is model building. A large EDA insight to inform model selection, feature engineering, and parameter tuning. Improve the accuracy and interpretability of your predictive models. Third one is continuous learning. Keep exploring and learning. Stay up to date with the latest EDA techniques and library in the Python to your analytical insights. Okay. This is all about the Python exploratory analysis. We will go through the all slides. Thank you for today. We will meet in next topic. Bye.